I was young, I was promised the world of the future would have robots everywhere. However, when I went to college and studied robotics, I discovered it required expert knowledge in lots of fields of engineering.
Robotics, in essence, is the connection and interaction of code with the real world around us.
When connecting code to the real world, we need some sort of bridge, some sort of device that acts as an intermediary between the real world and your application.
However, the first issue you run into with robotics is the lack of suitable controllers available.
We looked on the market and found that there was nothing powerful, easy to use, modern, and inexpensive.
Bottom line, there was nothing on the market that let me turn my ideas into reality.
Keeping this in mind, we created the Bowler Operating System, a suite of products that makes the design and manufacturing of robots simpler and more accessible than ever before.
We do this with the Dio, which connects to motors and sensors, and provides this feedback to Bowler Studio, our robotics design and development suite.
The Dio uses a novel high-speed connection to your computer, through which it is able to send sensor information to and receive motor commands from any connected application.
Bowler Studio is a Java application and app running framework that networks together diodes with standard computer hardware and libraries. Users can write Java apps from within Bowler Studio's built-in web browser.
We use Java for its speed and large support base. In fact, Java is the fastest growing programming language for open source development.
Meet Carl the Hexapod. In this footage, he's taking his first steps in our world. Carl is a great example of the versatility and power of the Bowler operating system. He started as a template in Bowler Studio. I adjusted his leg positions, his leg length, then twisted each leg to better support his weight. Then Bowler Studio figured out how to make him walk, and then generated the parts to be printed on a standard 3D printer. With this power and ease of use, you can take your projects to the very limits of engineering.
I'm Professor Fisher. I'm a faculty member at WPI in the Robotics Engineering Program and director of the Automation and Interventional Medicine Robotics Research Laboratory. We've been using the Bowler framework as a way to develop various different applications for medical robotics, spanning from socially assistive robotics up through surgical systems. We found that the Bowler framework is really an excellent way for initial development, debugging, and then ultimately clinically deploying all of these various systems through all the stages of development. In fact, at this point, we're actually developing an MRI-compatible robot for doing prostate cancer therapy, and the Bowler framework is at the heart of this system where that we're trying to use it for communicating between the hardware and the higher-level software.
We need your help to manufacture the second-generation Wi-Fi Dio so that you can control your creations wirelessly.
Your support helps us complete development of the Wi-Fi Dio, refine Bowler Studio, and create new creature apps as free updates to the Bowler operating system.
Thank you for your support.
Thanks for your help.
Thank you for your support.
Thanks for your help, guys.
Thanks for your help.
Thank you for your support.
Hey, from Neuron Robotics, thank you.